In this video, we're going to focus on finding the horizontal and vertical asymptote of a rational function. In addition, we're also going to find the slant or oblique asymptote if it's there. So let's begin. Let's go over our first function, y is equal to 1 over x minus 3. To find the vertical asymptote, set the denominator equal to 0. So if we set x minus 3 equal to 0, and if we solve for x, we can see that the equation of the vertical asymptote is x is equal to 3. That's all you need to do to find the vertical asymptote. To find the horizontal asymptote, you need to see if the function is top-heavy, the same, or bottom-heavy. This function is bottom-heavy. The degree of the denominator is higher than that of the numerator. Notice that the degree of the denominator is to the first power. We don't have any x variables on top, so we say it's bottom heavy. Whenever the degree of the denominator is higher than that of the numerator, the horizontal asymptote is simply 0. It's y is equal to 0. What you really need to do to figure out the horizontal asymptote, you need to find the value of y as x approaches infinity. If you plug in a very large number for x, let's say 1,000, y is going to approach 0. 1 over 1,000 minus 3 is very close to 0. It might be like 0.001 approximately, but that's close to 0. So let's go ahead and graph the equation. So the vertical asymptote is x is equal to 3, and the horizontal asymptote is y is equal to 0, which means that it's the x-axis. Now, it might be good to plug in a few test points. On the right side, the graph can be like this or like this. To find out what it is for sure, plug in a number for x that's greater than the vertical asymptote. So if we plug in 4, 1 over 4 minus 3 is 1. So we have the point 4 comma 1, which is over here. Therefore, the graph looks like this. Now for the left side, the function could be like this or it can be like that. So let's plug in a test point to find out if it's above or below the horizontal asymptote. So let's plug in 2 for x. It's going to be 1 over negative 1, which is negative 1, so we have the point 2 comma negative 1. So it's over here, which means that it's below the horizontal asymptote. And so that is the graph for this function. By the way, what is the domain and range for the function? The domain represents all the possible values that x can be. The only value that x can't be is the vertical asymptote. It's 3. So whenever you want to write the domain of a function, simply remove the vertical asymptote. The lowest x value is negative infinity. The highest is infinity. So therefore, the domain is going to be negative infinity to 3, union 3 to infinity. It includes everything except 3. Now what about the range? Whenever you want to write the range of a function, simply remove the horizontal asymptote. Notice that the lowest y value is negative infinity and the highest is infinity. But the function never touches the x-axis where y is equal to 0. So we only need to remove 0 from the range. So it's going to be negative infinity to 0, union 0 to infinity. Now, what about the end behavior of this function? What happens as x approaches positive infinity? As the function approaches positive infinity, notice that the y value becomes 0. So y approaches 0. That's the right end behavior. For the left end behavior, as x approaches negative infinity, it still approaches the horizontal asymptote, where y is still 0. So the end behavior of a function is usually the horizontal asymptote. So now let's move on to our next example. consider this function. Y is equal to 1 over x plus 2 plus 7. So what is the vertical asymptote for this function? So to find it, just like before, we're going to set the denominator equal to 0. So therefore, the vertical asymptote, if you subtract 2 from both sides, you'll see that its x is equal to negative 2. Now what about the horizontal asymptote? The horizontal asymptote for this portion of the function is y is equal to 0, because we still have a rational function where it's bottom heavy. The degree of the denominator is higher than that of the numerator. But notice that we also have a plus 7 on the outside. So the horizontal asymptote is going to be 0 plus 7. It's shifted up 7 units. So its y is equal to 7. So the graph is going to look very similar to the one that we had in the last example. So we have a vertical asymptote at negative 2 and a horizontal asymptote. It's very high up, it's at 7. Now let's plug in a few test points to see where the graph is going to be. So the vertical asymptote is at negative 2. So let's plug in a number to the right of negative 2 to see if it's going to be above or below the horizontal asymptote. So let's substitute negative 1 for x. So 1 over negative 1 plus 2 plus 7. Negative 1 plus 2 is 1. 1 plus 7 is 8. So we have the point negative 1 comma 8, which it looks like I plot the horizontal asymptote at 6. So I need to fix that. It should be at 7. But we still have the point negative 1, 8, which is somewhere over here. Therefore, we know that the curve is going to be above the horizontal asymptote on the right side. So it's going to look like that. Now, let's plug in a number to the left of the vertical asymptote. So let's replace x with negative 3. So negative 3 plus 2, that's negative 1. Negative 1 plus 7 is negative 6. So negative 3 and negative 6 is the point that we have. And that's below the horizontal asymptote, so the graph has to be in this region. So that's how you can graph a rational function. So what is the domain and range for the function? So keep in mind, for the domain, we simply need to remove the vertical asymptote. The lowest x value that we have is negative infinity, and the highest is infinity. So we just need to remove negative 2 from the domain. So x could be anything from negative infinity to negative 2, union negative 2 to infinity. So that's the domain for this function. Now for the range, all you need to do is remove the horizontal asymptote. The lowest y value that the function can be is negative infinity, and the highest is infinity. However, y can't be 7. It's not going to touch the horizontal asymptote, so therefore the range is going to be negative infinity to 7, union 7 to infinity. Let's try another example. Consider the function y is equal to 6x minus 18 divided by 2x plus 4. So how can we find the horizontal and the vertical asymptote for this function? So notice that the degree of the numerator is the same as that of the denominator. Both is to the first power. So whenever you see that, to find the horizontal asymptote, ignore the 18 and the 4. Because when x approaches infinity, the 18 and 4 are insignificant. If you plug in 1,000 for x, it's going to be 6,000 minus 18 divided by 2,000 plus 4, which is approximately 6,000 over 2,000, which is approximately 3. So therefore, to quickly find the horizontal asymptote, it's just going to be 6x divided by 2x, which is 3. So when x becomes very large, y approaches 3. That's the end behavior of the function, both the right side and the left side. So that's the horizontal asymptote for this function. It's y is equal to 3. Now, to find the vertical asymptote, we need to set the denominator equal to 0. And let's solve for x. So 2x is equal to negative 4 if we subtract both sides by 4. And then if we divide both sides by 2, we can see that x is equal to negative 2. So that's the vertical asymptote for this function. And so let's graph it. By the way, how can we find the x-intercept and the y-intercept for this function? It might be helpful to do that before we graph it. So notice that we can factor out a 6 from the numerator. 6x divided by 6 is x. Negative 18 divided by 6 is negative 3. And we can also take out a 2. So we can see that because we have x plus 2 in the bottom, the vertical asymptote is going to be negative 2. You could simply switch the sign from plus 2 to minus 2. Now notice that we have an x minus 3 on top. That means that the x-intercept is going to be 3. To find the x-intercept, you need to set the numerator equal to 0. So if you set 0 equal to 6 times x minus 3, if you divide both sides by 6, 0 divided by 6 is 0. So therefore, 0 equals x minus 3. If you add 3, x is 3. So that's the x-intercept for the function. So we have the point 3, 0. Now let's also find the y-intercept. To find the y-intercept, replace x with 0 and solve for y. So it's going to be 6 times 0 minus 3 divided by 2 times 0 plus 2. 6 times negative 3 is negative 18, and 2 times 2 is 4. Negative 18 over 4. We can make that negative 16 over 4 minus 2 over 4, because negative 16 minus 2 is negative 18. 4 goes into 16 4 times, and 2 over 4 is basically a half, or negative 0.5. So it's about negative 4.5. So therefore, we have the point 0, negative 4.5. That's the y-intercept for the function. So now let's graph it. So we have a vertical asymptote at negative 2, and the horizontal asymptote is y equals 3. So now let's plot the intercepts. So the x-intercept is 3, 0. Therefore, we can see that the function is going to look like this. It's going to be below the horizontal asymptote on the right side. Now, the y-intercept is at 0, negative 4.5. Maybe I should have plugged that in first before I graphed it. So this is a more accurate representation. Now, we need to check the left side of the vertical asymptote. So let's plug in negative 3 into the equation to see if it's above or below the horizontal asymptote. So it's going to be 6 times negative 3 minus 3 over 2 times negative 3 plus 2. 2 goes into 6 3 times. Negative 3 minus 3, that's negative 6. Negative 3 plus 2, that's negative 1. And 3 times 6 is 18. The two negatives will cancel, and so it's going to be positive 18. So therefore, it's going to be way up here. Either case, we know that the graph is going to be in this section. So that's a rough sketch for our graph. Now, what do you think the domain and range of the function is going to be? How can we figure it out? Feel free to pause the video and see if you can get the answer. So for the domain, all we need to do is remove the vertical asymptote, negative 2. X could be anything except negative 2. So it's going to be negative infinity to negative 2 union negative 2 to infinity. And for the range, simply remove the horizontal asymptote. So the range for the function is going to be negative infinity to 3 union 3 to infinity. Let's try this example. Y is equal to 2x squared minus 3x minus 2 divided by x squared plus x minus 6. So what do you think the horizontal and the vertical asymptote for this function is going to be? So to find the horizontal asymptote, let's look at the degree of the numerator and the denominator. Notice that it's the same. So therefore, we just need to look at the coefficients. We could ignore everything else. So it's going to be 2x squared divided by 1x squared, which is approximately 2. And so the horizontal asymptote for this function is y is equal to 2. Now, how can we find the vertical asymptote? What we need to do for this function is we need to factor the denominator and the numerator. And we need to factor this expression completely. So let's focus on that at the moment. So how can we factor x squared plus x minus 6? So notice that the leading coefficient is 1. In such a situation, what you need to do is find two numbers that multiply to negative 6 but add to the middle coefficient of 1. So what two numbers multiply to negative 6 but add to 1? This is 3 and negative 2. 3 times negative 2 is negative 6, but 3 plus negative 2 is positive 1. So the bottom part is simply going to be x plus 3 times x minus 2. Now what about the top part? 2x squared minus 3x minus 2. How can we factor that particular trinomial? So it's going to be a little different. It's going to take more work because the leading coefficient is not 1. It's a 2. So here's what you need to do. Multiply the leading coefficient and a constant term. 2 times negative 2 is negative 4. And then find two numbers that multiply to negative 4 but add to the middle term 3. So this is negative 4 and 1. Negative 4 times 1 is negative 4, but negative 4 plus 1 is negative 3. So now we're going to rewrite the expression, but we're going to replace the middle term, negative 3x, with negative 4x plus 1x. Notice that the value of the expression is still the same. Negative 4x plus 1x is negative 3x. So the value hasn't changed. We simply change it into a form that will allow us to factor by grouping. To factor by grouping, factor out the GCF, or the greatest common factor, from the first two terms. So we can take out a 2x. I'm going to erase this and I'll put it back in later. If we take out a 2x, what's going to be inside? 2x squared divided by 2x is x, and negative 4x divided by 2x is negative 2. Now for the last two terms, there's no GCF that we can take out, so if you can't take out anything, take out a 1. So on the inside, it's just going to be x minus 2. If these two terms are the same, then you're on the right track. So we need to factor out x minus 2. If we take out x minus 2 from this term, what's left over is the 2x. And if we remove x minus 2 from this term, what's left over is the plus 1 on the outside. And so that's how we can factor the numerator. So let's rewrite the equation. So y is equal to 2x plus 1 times x minus 2 divided by x plus 3 times x minus 2. So now that it's in factored form, we can now find the vertical asymptote. So what do you think the vertical asymptote is? Is it going to be 2, negative 3, or something else? Notice that we can cancel x minus 2. So the vertical asymptote is not x equals 2. In fact, x equals 2, the part that's canceled, is a whole. The vertical asymptote is the part that remains in the surviving equation. So the VA is going to be x is equal to negative 3. You said x plus 3 equal to 0. So now, how can we graph the expression? So what we want to keep is the surviving equation, which is the part that we have left over after we remove the whole. So we have the vertical asymptote at negative 3, and the horizontal asymptote is at y is equal to 2. Now the whole is on the right side of the vertical asymptote, so we really don't need the x and y intercept for this function. Let's find the y coordinate of the whole. So you want to plug in 2 into the surviving equation. So it's 2 times 2 plus 1 over 2 plus 3. 2 times 2 is 4 plus 1 is 5. 2 plus 3 is 5. 5 over 5 is 1. So it's going to be 2 comma 1. So it's somewhere over here. So the whole is also known as a point discontinuity. The vertical asymptote is an infinite discontinuity. Now, we need to plug in a point less than or to the left side of the vertical asymptote. Since the vertical asymptote is at negative 3, let's plug in negative 4. So 2 times negative 4 plus 1 over negative 4 plus 3. 2 times negative 4 is negative 8 plus 1, that's negative 7. Negative 4 plus 3 is negative 1, which is positive 7. So we have the point negative 4, positive 7, which is probably going to be way up here. So at least we know the graph looks like this. Now, what is the domain and the range for this function? Be careful now, because we do have a whole, and you do have to take that into consideration. So x could be anything from negative infinity to infinity except for two things. We need to remove the vertical asymptote because x cannot be negative 3. The curve never touches the vertical asymptote. And also, we need to remove the x coordinate of the whole, which is 2, because x will never be 2 since it's a point discontinuity. Therefore, the domain for this function is negative infinity to negative 3, since negative 3 comes before 2, and then union everything between negative 3 to positive 2, and then union 2 to infinity. So we just need to remove the vertical asymptote and the x coordinate of the whole for the domain. Now for the range of the function, y could be anything from negative infinity to positive infinity. But we need to remove the horizontal asymptote, and we need to remove the y coordinate of the whole, because y can't be 1, nor can it be 2. So therefore, the range is going to be negative infinity to 1, which is the y coordinate of the hole, union 1 to 2, where 2 is the horizontal asymptote, union 2 to infinity. So this is going to be our final example for today. Y is equal to 2x squared minus x plus 1 divided by x minus 2. So go ahead and find all the asymptotes for this function. So to find the vertical asymptote, we simply need to set the denominator x minus 2 equal to 0. Therefore, x will equal plus 2. Now, what about the horizontal asymptote? Notice that the degree of the numerator exceeds the degree of the denominator, so it's top heavy, which means that there is no horizontal asymptote for this graph. Now, because the numerator exceeds the denominator by 1 degree, we do have a slant or an oblique asymptote. So in order to find that, we need to use long division. Two x squared divided by x is 2x. And then we're going to multiply. 2x times x is 2x squared. And 2x times negative 2 is negative 4x. And we have to subtract. 2x squared minus 2x squared is 0. Negative x minus negative 4x, that's the same as negative x plus 4x, which is positive 3x. And you can bring down to 1. So now let's divide. 3x divided by x is 3. 3 times x is 3x. And 3 times negative 2 is negative 6. So we need to subtract. 3x minus 3x, well, that cancels to 0. 1 minus negative 6 is the same as 1 plus 6, so the remainder is 7. Now we don't need to worry about the remainder. This is what we need. The equation of the slant or the oblique asymptote is y is equal to 2x plus 3. Now the next thing we need to do is we need to factor the numerator to see if x minus 2 is a whole. We really didn't check that, but we should. Because if it's a whole, then the vertical asymptote won't be x equals 2. So let's double check. So we have a trinomial where the leading coefficient is 2. So we need to multiply the leading coefficient by the constant term. 2 times 1 is 2. Now what two numbers multiply to 2 but add to the middle coefficient, which is negative 1? The only numbers that multiply to 2 is negative 1 and negative 2, or 1 and 2. None of these add up to negative 1, so we can't factor it, which means that x minus 2 is likely to not be a factor. So let's go ahead and graph the equation. So we have a vertical asymptote at 2 and a slant asymptote at 3. So this is a linear equation. It's in the form y is equal to mx plus b. M is the slope, b is the y-intercept. So the y-intercept is 3. So the graph is going to touch the y-axis at 3. And the slope is 2, which is the rise over run. So it's basically 2 over 1. As you move 1 to the right, you need to go up 2. 1 to the right, up 2. Or you can go backwards, 1 to the left, down 2. And so we can graph a rough sketch of our slant asymptote. Now we need to plug in 2 points. one to the left of the vertical asymptote and one to the right to see where the graph is going to be. So let's plug in 0 for x because that's going to be the easiest. If we plug in 0, it's going to be 2 times 0 squared minus 0 plus 1 over 0 minus 2, which is 1 over negative 2. So we have the y-intercept, which is 0, negative half, or 0, negative 0.5, which is somewhere in this area. So therefore, we could say that the graph is something, it's going to look something like this. It's not going to be in this area. It's going to be below the slant asymptote. Now for the right side, let's plug in 3 into the equation. So 2 times 3 squared minus 3 plus 1 over 3 minus 2. 3 squared is 9, and 2 times 9 is 18. Negative 3 plus 1 is negative 2. 3 minus 2 is 1. So it's 16. So we have the point 316, which is probably way up here somewhere, which tells us that the graph is going to be in this section. It won't be in this section. So that's the rough sketch of our graph. So that is it for this video, and thanks for watching and have a great day.